alkanes are generally quite unreactive, but cycloalkane systems such as cyclopropane and cyclobutane can be very reactive, and this is because of the ring strain. Here for cyclopropane and cyclobutane, the ring strain values are very high and then they drop off suddenly. We'll have a look at why. We'll need to look at the bond angles and the Newman projections. Here these bond angles are 60, here they're 90. If we recall the shape of an sp3 hybridized molecule, it's tetrahedral. That means these bond angles are 109.5. All of these bonds are sp3 hybridized, which means that these bond angles are being compressed. So as a result, that compression causes ring strain. It's one of the parts of it. Cyclopropane is a planar molecule. It's flat. Just the way this picture is, that's the way it looks like. So as a result, if we take the Newman projections to something that is flat like that, they're going to be superimposed over each other, precisely like this. And this ring is, there's no way for it to maneuver at all. It's locked in place. As a result, there will be repulsion between these two things. So as we continue going down the chart, we'll see why it begins to reduce. So next we have cyclobutane. It has bond angles of 90 degrees. It has a lot of strain there, but it's going to be lessened because cyclobutane is not a planar molecule. The extra carbon allows it a little bit more mobility within its ring. So it can bend itself like this. This is the way that cyclobutane normally is going to be. And if it's bent like this, when we have a look at the Newman projections, they're not superimposed. They're still quite close, but it's still not the same as the cyclopropane system where they're exactly superimposed. This is lesser in energy than this one. So it causes a reduction in torsional strain and therefore reduces the total ring strain. And lastly, we'll look at cyclopentane. Cyclopentane has one more carbon added to it, and as a result, the bond angles are a lot closer to 109.5 than cyclopropane or cyclobutane. So the ring strain is reduced enormously. And also, the extra carbon gives it much more mobility. This is the way that a cyclopentane might appear. It can form flaps like this. Imagine this was a flat part over here. And this flap can fold up to reduce the torsional strain. This is supposed to be, maybe it's hard to tell, but this is supposed to be more spread out than this one. So since these carbons have more mobility, they have more ability to twist because they have a bigger ring to work with. It's not even so much a bigger ring, but there's less bond strain here. Since these angles are larger, they can twist more. And when they can twist more, they can spread the angle between these two things out more, reducing the total ring strain.